Okay, so this is a mesh model in SolidWorks of the type that you might capture if you were scanning into SolidWorks. And all I've done to this mesh model, other than loading it into Inspector, is I've fitted 3 features to some of the flat faces on the model. So you can see I've got 3 planar features, plane 1, 2 and 3, that have been fitted to the model. The display of the model in the viewport there, I've switched on edge display just to prove that it is a mesh. Normally you would have the display set to smooth and curve, something like that. So there's no need to worry about that. You don't have to. It was just to illustrate the point that it was indeed a mesh model. So I have the mesh model already exported as an STL. I'm going to export the features now as well. So I'm going to select the features, export, and I'm going to export these as the only format that's available for export of features, really, in terms of using them downstream in a CAD system, and that is the IGES format. So I'm just going to give these a name. So I'm just going to call it angled box, which is the name of the scan or the mesh file that I imported. So they've been saved now. So what I can do after that is I can now go into SolidWorks and import the mesh, and then import the IGES features as well, all into the same part. So I'm just going to do that now. So from within SolidWorks now, I just need to make sure that the Scan to 3D add-in is switched on, so I can do that in the add-ins menu. And then if I browse and find my STL file and use the Scan to 3D mesh import option down here, so there's my STL that I want to bring in. So open that using the add-in. And then typically, if you gain this mesh data by scanning techniques, you might have a few holes and a few errors, maybe topological errors in the mesh. So generally speaking, you would use the mesh preparation wizard just to help you correct any of those errors. As it happens, with this example, I don't think we're going to need to use any of these tools, but you might use a little bit of reduction on your mesh just to reduce the number of triangles down under, say, 1,000,000, just to get the size of your mesh more workable in terms of speed of SolidWorks calculating things that you're doing. I'll probably not fill these holes, so I want to clear the selection here. And you'll probably be the same. If you're working from your mesh data, you don't really want to create any geometry that wasn't there on the original scan, because that's quite dangerous in terms of making assumptions about the shape of things that aren't based on the actual item itself. So I don't want to launch the surface wizard, so I'm going to untick that. So there's my mesh imported now. If I want to work with that in terms of taking measurements or looking at the geometry a little bit more clearly, I have to convert it from this mesh import into a mesh body. So that will either be a surface body, if your mesh has holes in, like mine does, or if you happen to import a mesh which is entirely free of holes, so it forms a watertight outer surface, then when you convert to a mesh body, you'll end up with a solid body. But for our purposes, a surface body is much more useful. So that's good. In terms of our scanning workflow, it's very rare that you will get a complete scan of an item, especially items that have little internal sort of areas that you can't easily get the laser light to bounce back from. So they're partially obscured by other geometry on the part. So That's frustrating in terms of getting an entire scan of a part, but it works in our favour here because it means that when we convert to a mesh body, the converted body will be a surface, and that's much better for our workflow. So convert to mesh body. I can't click directly in the graphics area here to click on this mesh body, but I can find it in the feature list here and click on it there. So I'm going to accept that, and then what's happened here is it's hidden that original imported mesh, and it's converted it instead, as I said, to a surface body, and it's listed up here as well in the surface bodies folder. So now that we've done that, we could use some slicing tools to set up some slices through this object. I could slice down on the top plane here because the object appears to be sat on the top plane, so that will give me the perimeter shape down at the bottom, or I'm hoping it would. So let's try that. So there's the slicing plane. The default is that the system tries to give you 3 slicing planes spaced evenly away from the original one. In this example, I only want a single slicing plane, and I just want it down on the bottom of the part on its perimeter just to get that shape. So if I look down from above, you've just got to check that the boundary arrows here are big enough to encompass all the geometry of your part. So if they're not quite large enough in one direction like that, you won't quite capture the entire boundary. It will kind of end where the boundary of this rectangle is. So if you make sure of that, if you want to preview what that slice is going to look like, you can switch preview on here, and it should give you an indication. So let's try that, and we may be a little bit too low, so it's telling me there's no intersection with the part. So what I'd have to do there is I'd have to create a plane which is slightly above this top plane in order to intersect with the part. So I'm going to do that now. So in features, reference geometry, planes, I'm going to use the top plane as a reference. So I'm going to make a plane which is parallel to the top plane but at a certain offset away from it, and I really can put quite a small value in here. So I'm going to go for 0.01 of a mil and see if that now works. So that should be intersecting with the base of the part now, but let's see. So back into mesh modeling, find the slicing tool. If you can't see the slicing tool up here, you can just start typing slice up in this search box and it will find the tool for you. And then if you haven't got it in your mesh toolbar and you click on this little eye, what should happen is the arrow will automatically move to where that slicing tool is located. So I believe it's located normally in the insert menu over here. Well, I've got mine located on the mesh toolbar. If you want to drop any icons onto any toolbars, you can by searching for the icon up here and then dragging and dropping it on any of the command manager areas that you wish for that icon to be included in. So that's all I've done in order to get that icon up here. So I'm going to use this new plane as my slicing plane. I don't want 3 offsets again. And then if I have a look at the preview, yep, it's grabbed me a perimeter shape. Now, granted, there'll be a slight discrepancy there because this plane is fractionally, is a very small amount above the top plane, but I'm willing to forego that accuracy. I think I'm down at the 2nd decimal place in terms of millimeters, so that discrepancy is minimal at most. So then what I do is I probably create some other planes, so you could do some offsets from either the right plane or the front plane, and then I could create some more slices using those as well. And I could work from these slice shapes when I create my sketches. So I would maybe sketch on the top plane, and then I can if it's becoming problematic to see the mesh, it's kind of obscuring where that slice is, what I can do is right click on the mesh itself and say hide. And then it's much easier to pick up on this slice shape now. So if I wanted to draw some lines here, I could do just to capture that shape essentially, and then put some dimensions on my sketch that holds it to be exactly the same size as this this slice is here. So that might be a useful workflow for using the imported mesh as a reference. In addition to that, I can also import some of those IGES features as well and use those as a reference. Specifically, I've got this angled face on the top of this box, and it's not sloping exactly in the direction of either one of these two primary planes. It seems to be sloping at some strange arbitrary angle off to the side. So if I import those IGES planes, they might be useful to try and figure out how this face is leaning relative to the front plane and the right plane. So that's what I'm going to do now. Before I do that, I've got to save this part as a SolidWorks file. So I'm gonna click on save and give it a name. So I think for this example, angle box test is what I'm gonna call this. So that's saved. That's an important step, otherwise the next step that we're about to do won't work correctly. So make sure that you save it, and then insert, and we're going to insert a part into this part here. So you can do this within SolidWorks. So insert a part. It will allow me to then browse for the IGES file. So I'm going to filter my files down to only showing IGES files. There's the exported IGES features that I exported from PolyWorks. So I'm going to open those. And then when they import, it's a little bit difficult to tell that anything has happened, but we'll address that in a minute. We'll hide the mesh so that we can see the planes more clearly. But what the system does by default is it opens the move or copy tool to give you the option of moving those planes around. And if previously you'd moved the mesh slightly, as we did in some of our previous tutorials, we just kind of nudged the mesh into a better orientation, then you'll have to move your IGES features by a corresponding amount, or by the same amount that you did with the mesh, in order to have the IGES features align with the mesh as they did in PolyWorks when we exported this thing. So when they came out of PolyWorks, the two will have been in perfect alignment, the features and the mesh, because the features were directly created from the mesh. But if you've moved the mesh slightly during the import process or just after, then you'll have to take a note of how you moved it and in what directions, X, Y or Z, and just move the IGES features by a corresponding amount. And the way that you would do that is you kind of browse and find what the IGES features were called. So there's one of them, there's the other one, and there's the other one, and then you can just put some distances in any of the directions, the three axes. So that's relatively easy. As it happens, we don't have to do that because I haven't moved the mesh when I imported it. I just left it wherever it happened to be. So I'm going to cancel that menu. So I have my features. I'm going to hide the mesh body now, just so that I can see these planes a bit more clearly. So there they are. Technically speaking, PolyWorks does call these planes, but within SolidWorks, they're not true SolidWorks planes like the front plane, the right plane and the top plane. They're what's known as planar surfaces. So they have boundaries at each side, whereas any plane in SolidWorks is actually infinite in size. So the planes appear to stop at this point here, but in actual fact that's just for our viewing convenience. The planes actually extend infinitely out into the SolidWorks workspace. So these are planar surfaces. We have one that corresponds to the angled top face there. And in terms of dealing with that now, what I'd really like to do is I'd like to project from this side of that surface off until I hit the front plane here, and then get a reference of what that angle is relative to the front plane. And likewise, I'd like to project off away from this edge of the surface till I hit the right plane. And then I'd like to take a little reference of what the angle and position would be relative to that plane. So there's a tool when I'm dealing with surfaces that allows me to do just that. So I'm going to hide these other two planar surfaces because it may get confusing as we're kind of dealing with this one. And I may even go into slice 1 and just hide that slice as well. So the only things I can see are the primary planes and this planar surface. So the next thing I'm going to do is in the surfaces tab. So if you can't see the surfaces tab, just right click on any one of the other tabs and switch that tab on. And what I'm going to do is I'm going to use the extend surface tool. So it essentially does exactly what that description would lead you to believe, which is it allows you to pick edges on an existing surface. So I'm picking that edge there and that edge there, and then if I zoom in I might become aware that there's a series of edges here. I could extend all of those. It won't damage this process if you do, but it's not really required. And all I'm going to do, I don't quite know how far I need to extend. Clearly this edge is already past the right plane. I can see that if I look down from above. It's already gone past the right plane, so that's okay for our purposes over there. But if I extend outwards until I'm fairly sure that I've hit the front plane as well, or I've gone through the front plane there. So I've passed through the front plane here, and I've passed through the right plane over here. So that should be okay for the next step. So I'm going to accept that. So that's what my surface has turned into now. And then what I can do is I can use these two planes to trim back that surface so it's exactly in line with the right plane and the front plane. So that's what I'm going to do next. So trim surface is the tool that I'm about to use. And all I have to give this tool is what I want to use to trim the surface. So in this trim I'm going to use the front plane as the cutting tool. And which sections of the surface do I want to keep? So which section do I want to keep? I want to keep this area here. So there's an area that pokes through the front plane that I could say keep that. So it will keep a portion of this surface on either side of the front plane. So I want to keep this side. So then I can accept the tool and it's trimmed it back onto the front plane. So it exactly intersects with the front plane now. That's going to be useful in a second because we're going to put a little sketch on there that tells us what that angle is. So I'm going to do the same procedure again using the right plane this time. So trim surface. What is the trim tool? It's not the previous surface, it's the right plane this time because that's going to be the cutting tool. Which section do I want to keep? I want to keep this section here and then OK the tool. So we've extended too much and then we've trimmed back, so we've neatened that surface up. We've made it exactly hit the front plane and exactly hit the right plane. So now what we can do is we can put sketches on both of these planes, and we have a common point where these two line sketches will meet. There's a point that is both on the front plane and on the right plane. So we can kind of reference that point in our sketches. So I'm going to sketch on the right plane first. So click on the right plane, sketch. It's a bit difficult to interpret what I'm seeing there, so I'm going to kind of rotate my view around so I can understand what I'm viewing a little bit clearer. We don't normally sketch at an angle like this, but it's quite useful in this instance. So I'm going to get my line tool and I'm going to stick one end of the line onto that point there, that corner on the surface. And then I'm going to drag along this edge. I don't want to hit the exact midpoint of the edge. I just want to kind of go 2/3 of the way along. And then I'm going to press escape because I don't want any more lines. So now I have a line that is exactly angled to create that surface. And what I'm going to do next is I'm going to create another sketch on the front plane and put a line exactly in line with that edge. And the combination of those two will describe the angle of that top face, but it will also describe the height of that top face above the top plane. So they're two key dimensions that define where that top plane, that top surface of my part is in space, essentially. So as with all these reverse engineering activities, we don't want to leave this sketch line attached to the imported data. We want to put some dimensions on it ourselves. So I'm going to delete these two relations. So I'm deleting both those coincidents. And then I'm going to dimension up from the top plane to that point there. It will be kind of an arbitrary dimension. I suggest with these dimensions that you just leave them at whatever value, whatever arbitrary value they happen to come out at. So I'm going to leave that. Then I'm going to put an angle dimension on this line. So I'm clicking on the line and clicking on something to reference, maybe the top plane. So there's an angle dimension. Again, I'm just going to leave that for the time being on the arbitrary value that it happens to be on. And then I am going to put some relations in. So I'm going to put that point and the front plane should be coincident with each other. And that should lock the position and the angle of the line down fully. The only unknown now is the length of this line, which if you're using good practice and you're trying to fully define all your sketches, you could just put some arbitrary length on there if you wanted to. But it's not really required. And as I've just dragged that line, you can see, be very careful because it's just automatically added a coincident relation back in. So I'm going to delete that again. So you don't want any kind of remaining dimensions that relate this thing directly back to the import. We want to be in control of its dimensions. So I'm going to accept this sketch, and then I'm going to repeat all that process but on the front plane this time. So sketch, rotate my view so I can see a little bit better kind of what's going on. So I'm sketching on the front plane, get my line tool, click and click, then delete both of those relations because I don't ultimately want it linked back to this. I want to be in control of it. Then probably what I'll do is I'll temporarily hide the surface that I'm working from because I've finished with it now. So then I can put my angular dimension on like that. And then what I can do is I can say at the end of this line and the line on the neighbouring sketch, make them pierce one another. So that's a new type of relation that we haven't really used before. So it's essentially coincident between a line and a point. And then I could put a length on here again, but I don't really need to. It's okay in terms of these sketches to leave that slight under definition just to do with the length of these lines. So that would be acceptable in these sketches. We've defined everything else that is important to us. So now I've got those two lines. So what I can do with those is I can create a plane. So I can create a plane, a true SolidWorks plane, using that line as input and that line as input. And then I can accept that plane. And then if I show my planar surface again, these two should be, broadly speaking, exactly collinear with each other or coincident with each other. So that's how we get a true SolidWorks plane from an imported Polyworks feature. And then what could I do with that? Well, one of the things that I could do is if I sketched a perimeter shape. So I'm just imagining that the perimeter of this box now is just a simple rectangle, let's say. I know for this box it isn't quite as simple as that, but let's say it was. And I wanted to create an extrude. So just a standard extrude from that sketch. What I could do, instead of setting just a blind depth for that extrude, I could say extrude up to surface and I could use that new plane as a surface to extrude up to. And now I have a top face which is exactly coincident with the top face of the scan that I was working from. So that covers quite a lot of the steps that might be useful. So importing those STL scan mesh files, doing some slicing through those files to kind of see what the cross sections look like at various points, and then you can use that as a guide for your sketches later on. And then in tandem with that, you can bring in the IGES features as well from PolyWorks and use those in useful ways as well. So the types that we brought in were all planar surfaces, or in PolyWorks language, planes. But you can bring in cylinders or points or lines out of PolyWorks as well, and they will import just as easily using the insert part method that we just used before. So you can use a combination of the imported IGES features and the imported mesh itself to kind of slowly work your way towards replicating the geometry of that part that you're working on. Okay, that's the end of this tutorial.